So next we have our last and amazing speaker, Iris, who is talking about capturing and discovering things through technology that we would not normally know. Some incredible technology. And you taught yourself how to code and you set up your own business, having come from archaeology. So incredible journey as well. So really looking forward to hearing about this one.
Yeah, well, thank you for inviting me to speak as well. It's really exciting to be here and hear all the exciting talks. And it's slightly different, some of what I'm showing to what I was hearing, and I love all that kind of more artistic sides of what we're doing. But we're kind of working very, very technical on less artistic things. But yeah, so a bit about me. So yeah, as you explained, like my background is in archaeology. I'm from the Netherlands, where I studied archaeology at Leiden University. I thought it was a fun study to do, but then yeah, I got more interested in the computing side, and then in the masters really found that I could use some automation to discover archaeology, but it was very considered by archaeologists as something that could not be done at all. And so I wanted to prove them wrong, and I saw the self-driving cars on the road, so I thought we could use perhaps similar technology to then apply that to archaeology. So I went and learned how to code in a coding course, and then applied for PhDs, and luckily got funded by the Ordnance Survey. So it's got very lucky in the right time, right place, kind of to get it all off the ground. And it worked so well that already from the start of the PhD I was thinking about what I'm going to do after, and I started Archaeology around the time that I finished the PhD to really leverage the technology that I'd built. We discovered new archaeological sites, and I didn't want to do it in an academic setting where you just make small incremental changes. You just publish papers in an academic setting and you don't really go out there and make bold discoveries like, can we do this small thing across the country, across the world, where we can really build big teams. In a commercial setting, you can build much bigger teams, and yeah, have a larger impact and be in control of what that impact is. So yeah, and my experience since starting the company has been amazing. Been having lots of support from different opportunities and grant bodies in the country. So that's been great. And then we've got customers now with the Forestry Commission and the National Trust. So I'll go through a bit of a whistle-stop tour of the different ways in which we have been able to use AI to discover different archaeological sites and historical features, which are then being used by these different customers to actually impact landscape design and yeah, changes that are about to happen. The landscape is obviously an area of lots of change, either by like climate change mitigation, biodiversity improvements, and or just construction happening, and like how do you yeah, how can you need to know about where the archaeology is basically to be able to protect it, or to know about where it is before you develop something, because if you find it during a construction project, then you will yeah, get huge delays, and that can yeah, be hundreds of thousands of millions of pounds as well. So the developers don't want that, so they would like us to discover the archaeology before they go and put a spade in the ground. So a bit back on like what is actually the discovery of archaeology through AI. So we use different Earth observation sensors like satellite images and LiDAR data. So the second image there, you're looking at the LiDAR image. With LiDAR is laser scanning from the air, so from an airplane or a helicopter or drone, and it takes laser points. So it measures the distance from the ground to the scanner, and then you can get a 3D view of the landscape. And this is just highlighted to see the local earthworks on the ground. So here we're looking at some round houses and small cairns, clearance cairns from agricultural practices on the Isle of Arran in Scotland. And how the AI works is it is trained by experts. So archaeologists here have drawn circles around the actual objects that they are interested in. And when you do that on a large scale, then the AI can learn from those locations without actually telling it to look for circles. It will internalize that, oh, I've seen a lot of circles. And that's how, like, yeah, the AI, the neural network in the process works. So yeah, in my master's I was feature engineering, so I was telling it, look for circles of roughly this size and shape. But when I went into the PhD, it was about machine learning and about giving it just examples of what it should be looking at. And then within that network, it learns lines, edges, color blobs and differences. And so it works actually how a human brain works, like a child who is learning how the shapes fits into the different boxes, all the different shapes. The square doesn't fit into the circle. So it just learns in that way as well through lots of experience of going through that. Yeah, what comes out of that in the end is a trained model that can be used in that landscape and can even be used in different landscapes. But of course, as the archaeology changes in different landscapes, you have to retrain the AI to fit all the different landscapes, and so it's a process in archaeology that's quite difficult, but also experts need to retrain whenever they go to a new area and get more experience. But the great thing is that an expert who has been working in Scotland for 10 years can work in other areas as well more quickly than someone who's just a novice. So you just build on top of that experience a lot and become much more cleverer over time. So what we've been doing is training on different types of sites that we find across Scotland in this case. So we worked with Historic Environment Scotland and trained this AI, this model, if you will, on like trackways, banks, ridge and furrow, lazy beds. So it's archaeological sites from different periods. It's from the prehistory to the more recent farmsteads that have fallen ruined but are very interesting in the landscape. And in England as well, we've trained it on a smaller portion, but of lots of varied different sites. So on hill forts and burial mounds and linear earthworks and quarries as well. Developers love us to find quarries because they're potential like risk of contaminated sites. So they want to know about it. It can also potentially collapse or something like that. So it's a historic feature, but then there's multiple uses on the modern landscape why people are interested in those. So a little bit more on like the more specific commercial projects that we did is here looking at ridge and furrow. So this was with the Forestry Commission. We were looking at, can we detect not just where the ridge and furrow is, but can we also extract more information from the ridge and furrow? So can we understand what the preservation is? These LiDAR images show us the 3D map of the landscape, so not necessarily what's underneath the ground, but more what different humps and bumps we still have on the surface. Because as well, for the Forestry Commission, that's important because they don't want to grow and plant new trees on these sites because they're actually really a part of the landscape, and if they're really clear to be seen from a road or somewhere, then actually it's really a location that you would want to preserve because it's actually a more interesting part of the heritage. And if it hasn't been plowed for a long time, it also becomes species-rich grassland. So you have more kind of biodiversity aspects to such an ancient site that has been preserved in such a way over such a long time, since the medieval period when these were brought in as an agricultural purpose. So these were with ox-drawn plow. These were cultivated lands. So yeah, and then also can we date them was an interesting question. Some are from the medieval periods, but as you get closer or go through time, they started using more steam plowing, and so you get more straight ridges rather than the ox that draws and creates these nice curves in the landscape. So yeah, we were looking at all that, and here in the image you can see the height that we were able to extract from just the preservation. So looking at where the lines are and then looking at the height across that field, so you can get a broader picture, and you can also decide, okay, what's the threshold at which we're going to preserve a site, and where do we decide that, yeah, actually here can be woodland creation. And then we were able, based on those criteria of the curving of the field and the straightness and the narrowness of the fields, you can decide where something is medieval, post-medieval, or where it's perhaps somewhere in between. And you get really rich metadata from that. And we have been comparing that as well to how it looks in the field. So here's an image of what that looks like in the field, these ridges. And this is a site that was compared from field work to then our assessment. And it's here it's written what the field work specialist said, and it comes across as the same thing. Yes, it's a medieval site, well preserved. So this is one of those sites that we would like to preserve and not see planted with new trees and woodland. And then here, let's see if it works. Yeah, just a little you going through the landscape and seeing like where these the ridge and furrow appear. So you can see that actually they appear quite regularly across the country, across this landscape at least, and then at different heights. So red here is higher and better preserved, and going down to like blue where it's not well preserved. So then that was nice on a small scale, but LiDAR data is available across the country. So we've been able to download all the LiDAR data, process it in a way that our AI can interpret it the best way, and then we can get these maps of like, oh, where actually is all the ridge and furrow in the country. So we are able to establish where the hotspots are of ridge and furrow, and there's huge like research potential in something like this. And that's really exciting for research, but also again for organizations like the Forestry Commission who have to make advice across the country for different woodland proposers, and now they can have that kind of feedback in a much more knowledgeable way, and it doesn't their specialists don't have to constantly look into the data to come up with the interpretation of the ridge and furrow of where it is. And to be honest, it actually wasn't a consideration because that was way too much work for them to do before. They wouldn't be able to do that. So now they finally can, and so it allows that interpretation where it was previously just kind of ignored. Okay, thanks. Yeah. And then when you start looking at a large landscape, you can also start looking at where the AI makes mistakes, because as soon as you scale up, like I was saying before of this example in Scotland, like here as well, you start seeing the mistakes in it where you're not expecting the AI to come up with things. So mistakes here are mainly drainage patterns, different drainage patterns. So ridge and furrow is a drainage pattern, but there's other drainage in the fens around like near Peterborough, and then also more in the Somerset there is also an area of lots of red where the AI made mistakes, and that's another drainage pattern then there. But also this small area there with the squares around, well, it's not small, but this is area around Salisbury where there's a lot of they follow rivers where there's actually water meadows. So that's a type site that is not ridge and furrow, but it looks very similar because it has that drainage type. So what then we do is we train it again on a different type of site like this, and then the AI learns to differentiate between those different patterns. But again, this is something that then was really a fortunate discovery for us, because actually these are also really interesting types of sites that they don't want woodland planting on, because those are really important for wetlands. So they have a different biodiversity value and also shouldn't be planted on. So it's fun discoveries that we're making along the way. So it's not just LiDAR data that we use, we also use historic maps. So here is an example of the discovery of, or training an AI on orchards, and then having the AI come back with those orchard patterns. A much simpler actually approach than what we were doing with LiDAR data, because the maps always look the same, or at least you hope so. But Ordnance Survey mappers of 1900 were also a bit creative sometimes with their drawings, which the AI doesn't appreciate. But yeah, here again we were able to do that on the national scale, and then we can see on the left the image is 1900 and 1950 and then today, so you can see the decline of orchards in different parts of the country. And as we're trying to rebuild some of the biodiversity in the country, looking at these maps and then promoting perhaps more orchard creations in areas where they have been lost, to perhaps try to help certain areas revive some of the history. And here is looking at woodlands, also again on a national scale, helping to promote woodland creation, where with the ridge and furrow we discourage it. With this one we promote it. This is a really good location. The seeds that have been dropped by those woodlands in the past are still good locations to revive the native species in those areas. Similarly with ponds, pond locations that are now lost and no longer a pond are still really good locations for putting ponds back in, because they have seed stores, seed banks kind of inside the soil still. So the biodiversity there recovers much faster if you choose one of those historic locations. And farmers can get subsidy as well, and it will be more if you plant in that location. And with biodiversity net gain, you can get all sorts of credits to make the landscape regenerate with this kind of solutions to put them back in. So, okay, yeah. So yeah, looking at historic maps again, looking at the boundaries, we can look at where hedges were. So hedges can be replaced in the same location. We understand where they have been destroyed, created, or retained throughout the landscape, and you can see the differences in the country. I wanted to quickly, before the end, I already told how we use that. Then finally, just an example of how we use satellite images, and this is an aerial photography, so looking at different crop marks. So archaeology can be shown through crop stress. These archaeological sites are buried in the ground, but once a year or once every couple of years, we can see them appear in the landscape when there's a period of drought, because the crops can't root very deeply, and so they're stressed in the summertime when it's really dry. And here you can see that pattern. So the AI has been able to as well retrain on these kind of types of sites and then discover again those patterns in the landscape. And here is an example of what it's found when it was looking for these kind of more square objects in the landscape. So here's then the manual interpretation. So the square things overlap with the square lines that they had interpreted manually. Yeah, so AI has come a long way. We've been able to use it in so many different ways, looking at lots of different shapes and sizes, not just the circles that I did in my master's, but now we can do all sorts of different shapes and have a real impact in the country to help revive biodiversity in some ways with a view on the historic environment. So, thank you.
Oh, amazing. Thank you.
If you want to get in touch with Iris as well.
Yeah, there's my information.
That was brilliant. I enjoyed that. Thank you.
Amazing example of how the passions of the past can just help us do better now, and like why understanding the past is so important, like literally from the marks on our landscape. So thank you so much for coming. That's incredible.
No worries. Thank you.